gateways. Can you guys hear me back there? No. No? How about now? Now. Okay. I'll try to talk louder. How about that? Is that better? Still? No? Okay. We'll go with that. All right. ZWave is a proprietary protocol by Sigma Designs. It is primarily used in home automation, security solutions, and smart metering. Sigma Designs, they've partnered with over 250 companies, including big names like Ingersoll Rand, ADT, Verizon, and LG Electronics. ZWave is based on the ITU-T G9959 recommendation. It specifies short-range narrowband communication in the sub-gigahertz spectrum. Depending on the country that the ZWave protocol is being used in, the frequencies will vary. Specifically in the US, it's 908.4. In Europe, it's, I believe, 860. So it just varies depending on region. This is a snapshot of the ZWave reference model with respect to the TCP/IP reference model. So the vendors differentiate based on the application layer and the routing layer, but all of them are based on the PHY and MAC ITU-T G9959 specification. In all ZWave networks, there are two types of nodes. There are control nodes and there are slave nodes. There's also a dedicated home ID allowing for network overlap without interference. In any given ZWave network, you can have up to 232 nodes. And Sigma Designs requires any ZWave developer to sign a non-disclosure agreement, and this prevents open source research. Therefore, little is known about the security implications of its use. This is a snapshot of the end devices. There's a smart switch, lamp module, door lock, and a Fortress water valve. So in ZWave, the control nodes are often referred to as gateway devices. They're trans-network devices. What this means is it's almost like a miniature router. This isn't it, by the way, not to distract you, but it's a trans-network device. So the homeowner or the user will send a Wi-Fi packet or some kind of command to the device from the Wi-Fi or WLAN interface. The router, the gateway takes that in and then sends out a ZWave command. So trans-network device, in Wi-Fi, out ZWave. Gateways can be used to access the devices locally or globally. So you could come home, set scenes, activate lights and switches, but you can also access your home or security solution from anywhere geographically with a cell phone app or any internet connected computer. And that's how the gateways are primarily used. But this obviously introduces an avenue of approach into the network, namely the internet. So primary use is global accessibility, but now you can kind of invite the world into your home per se. Snapshot of gateway devices. The one I'm going to attempt in my demo is using the Raspberry Pi with a Raspberry GPIO general purpose input output daughter card. And these are some other ones that I've worked with. But there are many gateways out there. All of them provide global accessibility. So gateway access is garnered through the wireless local area network backbone. And because of the chain of trust, you can say between the router and the gateway, once you have access to the local area network, you have access to the gateway. Also, social engineering attacks, phishing attacks, prompting the target to install malware on the device so that the attacker can get back-end access. Just different ways to access gateways and attacker. All right, so vulnerabilities are inherent to the gateways because many of them, not all, but many of them, lack of user validation or insecure web UI user interface. Lack of gateway encryption or transmission encryption on the gateway, and default enable and in-use services. And these inherent vulnerabilities can cause HTTP capture to use for replay and injection into the network, cross-site request forgery, enabling firmware modification, code execution as root, and backend access. And all of these have been demonstrated on varying gateways previously, and I've worked and played with a couple of them, and a lot of these gateways are vulnerable. And the reason behind that is a lot of vendors just want to jump on the bandwagon, the next big thing. I'm sure you guys have seen some of that, developing hardware systems and not really building it with security as its overarching theme. Security is kind of, I don't know, maybe a last step or step 4 or 5, but it's never through the entire process. So that's not really on the vendor's minds a lot of the times when they're developing these hardware devices. So 2015 stats for 196 million households. Just to give you a snapshot of how many households use Wi-Fi, wireless local area networks, about 45% are encrypted with WPA2, 18% with WEP, and about 7 or 8% with WPA. 11 unencrypted, and about 17% are unknown, and this is as of January of this year. So wireless security, Wi-Fi security can be cracked using open source tools. WEP does IV reuse, so that's a major flaw in WEP, can be easily cracked. And then WPA and WPA2, what I've seen a lot, even just scanning my neighborhood, you know, the SSID says this is the type of device, and a lot of homeowners don't change their default ID and password, so it's really easy to get into someone's Wi-Fi that way. They use weak passphrases. Password dictionaries can help greatly in reducing password cracking time. All right, so once the target's breached, once you're on the Wi-Fi, because this is the route we're going to take, we're gonna manipulate or compromise the insecure WLAN backbone. You scan for the target. So I guess first step in every attack is reconnaissance. You need to know what you're looking for, and if you Google all these gateway manuals, they have a lot of identified fingerprints. For instance, just by looking at the Raspberry website, the Raspberry Pi website for the ZWave chip, you know the ports that are open. Port 8083 takes you directly to the server. Port 8084 takes you to a remote login page. So a lot of these gateways have easily identifiable fingerprints. Operating systems, like, all right, this gateway I know uses this operating system, do a ZenMap scan of the wireless local area network, and you could easily find the IP address. Now that you have that, the gateway type, you could craft a packet to send into the gateway. So this is something kind of interesting. I did this work a couple months ago, and when I did it with the Raspberry Pi, they did not use any authentication whatsoever. And within the last month, they put in a UI authentication, and I was pretty impressed. I was like, wow, that's awesome that they did that. So crafting packets ahead of time helps, but if there's any UI authentication or a cookie used, the packet's going to be denied. So if you're on the wireless local area network, though, it's fairly simple to steal a cookie. So regardless of UI authentication or not, stealing a cookie and changing the HTTP post or GET requests, you can make it through actuate devices on the networks and manipulate the gateway device as you please. So now that we're in, we figure we can inject a rogue controller into the network. Now, this is the exploitation of a feature. It's not, I didn't find a loophole into the device, or it's just a feature, a horrible feature that some of these gateway devices have. So use inclusion and exclusion. In every ZWave network, you include and exclude devices. Generally from a portable remote controller like this, you can just put this into inclusion mode and then physically tell the device, all right, I'm going to put you into the network. Then the controller accepts that device. So that's how it's included. Similarly, to exclude, you physically put the portable controller in exclusion mode, and you physically touch the device and they exclude. The only way the device can be excluded from the network is if it matches perfectly with the device. So the device goes, okay, that's device 2 that wants to be excluded. I'm going to exclude device 2 and device 2 only. With gateway devices, like the Raspberry Pi, they allow UI, or they allow inclusion and exclusion from the user interface. You don't need physical access to the controller. Therefore, you can inject a rogue controller from outside the home, and this was tested up to 21 meters outside a home. If you get access to the wireless local area network, it's possible to inject a rogue controller into the network, maintaining access to the ZWave devices. So this one feature of UI inclusion, it creates serious implications. Just a step through of rogue controller injection. This is actually my home, what it looks like. Yeah, so my TV, everything. Washer and dryer not depicted, but that's where they would be. So this is a ZWave home automation network with a gateway and 6 nodes on the network. So step 1, wireless local area networks compromised. So think of it as, okay, I could crack your Wi-Fi password, that's fine, but what about a neighbor? Like, what if I was your neighbor? I mean, clearly I don't do good stuff, I guess, right? So it's just the wireless local area network security is pretty serious. Secondly, the hacker or attacker injects a HTTP inclusion packet to the gateway. So the gateway is now in inclusion mode, and we're going to use 2 controllers for this, and it'll be very evident why. But it's pretty much to cover your tracks. So the row controllers are set to replicate mode. So you set the gateway, you inject an inclusion packet to the gateway. You set both these to replicate mode. Controller 1 connects to the gateway and begins receiving all network traffic from the Raspberry Pi. Simultaneously, controller 2, it's not connecting to the Raspberry Pi because I don't put them both in replicate mode simultaneously. Controller 1 goes in replicate mode, connects directly to the Pi. There's one channel, and when I set this to replicate mode, it sniffs all the traffic that's going between these 2 devices. So this is the only device that's actually getting added to the network. This device is picking up all the same traffic, but it's not actually getting added to the network. 5th step, now both controllers have access to the devices on the network. They have the same home ID, and in ZWave protocols, if devices share the same home ID, they're on the same network. It's I trust you, you trust me, we have the same home ID. And so that's what's important. They get the home ID, and they can control devices on the network now. They're fully trusted. All right, so why 2 controllers? Covering your tracks. As I said, in ZWave Networks, when you add a device to a gateway or a controller, that device they're paired. You could add multiple devices, but in that one instance, those devices are paired. They're trusted. However, that device goes on the device list of the gateway. You cannot remove it unless you exclude the device. Now, there's some gateways that you can just right-click and delete from the UI. Those are really easy to cover your tracks. The Raspberry Pi provided a little bit more difficulty, so I decided to do that with 2 controllers. But once in the UI, a homeowner would say, hey, there are 2 devices on my network. There's only supposed to be 1. Obviously, that's fishy. Reset my network, delete everything, freak out, call the cops. Probably not, but that's what they would do. So adding 2 row controllers to the network, technically only 1 because this is sniffing the traffic, I can then exclude this from the network, which doesn't affect this. So now the device list goes from 2 back to 1. This is excluded from the network, but this still maintains the home ID and the device list. You can still control the network from outside the home. And the cool thing about these portable controllers, the gateway, the homeowner has to have access to the gateway to actuate devices. So Wi-Fi in, Z-Wave out. This just communicates in the sub-gigahertz spectrum. So if you unplug the gateway, or you take the gateway off the wireless local area network, this is a 908.4. It doesn't need the gateway to access the devices anymore. So you still maintain persistent access backdoor to the devices on the network. All right, so lastly, you inject an HTTP exclusion packet, set this to exclusion mode. The gateway picks it up like this controller wants to be excluded from my network. I'm going to remove it. So the first controller is removed from the network, and as I said, the secondary controller that was never actually added, just sniffed the traffic, maintains the home ID, and access to devices. All right, so I'm going to try a quick demo here. So before I came in here, they told me not to do a demo, just videotape it. I'm like, it's going to work. It was working. So I just, for some reason, it's not connecting to the Wi-Fi, but as soon as it does, which it should.
Did you sacrifice the demo guides?
Yeah, no, I didn't. I didn't do that. I don't know how much that would do, honestly.
Demo guides demand 2 shrubberies.
Yeah. Yeah, no, because this won't. So it just give me a couple minutes. You guys just talk, get to know each other. So yeah, just talk amongst yourselves. Bathroom break. Yeah. Talk about ZWave and how awesome it is. How big of a deal it is. Yeah, like. All right. So while this is booting up, or I'm trying to reset the router. Everything's plugged in. That's good. This guy is on. Actually, I don't have a different. No one has an Ethernet cable in their pocket, by any chance. Serious? I thought you were serious. I was like, what? That's awesome. And $20 would be great too. Wow. All right, we'll give this a shot. this. Just wait. We did. Thanks. Yeah, we do. Thanks. Actually, that should work. See this. Try. Cool, that works. Let me just try this. Ah, no. All right. All right, so because when I originally did this, Raspberry Pi didn't have any UI authentication. Now they do, and now you need to steal the cookie. Now that's fairly simple to steal the cookie, but walking you through to steal the cookie would show you how I would put it into inclusion, so it wouldn't be as cool. Because you would actually have to either capture a packet that is turning a device on or off, and then just put a new command in there that says add new node to the network, uses the same cookie, and it authenticates. So my cookie expired. Therefore, I'm getting I don't know if you can see the forbidden top right. So I'm just gonna, actually I can do it a different way, which would still work. All right. All right, this will work. All right, so what I'm going to do is set this to inclusion mode, and then add it to the network, and this is going to sniff all the traffic. Okay, I need to go back. And by the way, this is connected to this ZWave switch. I just plugged it in. It's just a power switch. So when this turns on, that light will turn on. I figured you probably wouldn't hear the click from all the way back there, so that red light will help out. Okay, so replicate, receive. All right, so now this is being added to the network, and the replication started for this one. So it's scanning the traffic between both devices, right? One thing I need to show you before I forget. I don't want to miss that. This is really important. Okay, so there are two devices present. I should have showed you that before, I forgot, but originally there was one. There was only the power switch device. Now there are two devices on the network, the power switch and this device. The gateway doesn't recognize this device. Now we're going to exclude this device from the network. That's in exclusion mode. And go to here. And this is another way. I just did an alternate way in case burp broke for some reason, burp proxy. But if you go to the Raspberry website, they give you all the commands to run, like how to turn devices on or off. So these are free on the interwebs to Google how to turn devices off or on or include a device via Raspberry commands. And that's how I got those commands. So this is currently in exclusion mode, waiting for the gateway to say, hey, exclude me from the network. All right, let's see if that worked. All right, one device on the network. All right, so it excluded it from the network, but we need to confirm that this guy works. Can I get a drum roll? Sweet. Awesome. Hey. So just to prove, so it's all added through the gateway. Unplug the gateway, take it off. You'll see that it's going to try to go back to the IP address, which is this IP address. I'm not doing any sleight of hand. It's trying to access the gateway, and it can't because it's unplugged. So it still works. So you don't need to maintain access to the gateway device. Sub-gigahertz spectrum only, and you kind of own their house. And not for anything malicious, just to sit outside and turn their lights on and off to annoy them when they're watching a movie or something. That's what I use it for. So
Just do a strobe light.
strobe, exactly. Yeah, cool. All right, that concludes my briefing. Are there any questions?
What makes the handheld controller?
Aspire RF. You could just Google handheld controllers. There are multiple ones. This is a little bit more expensive. It comes with a wall mount, so you can use both. I think this one was like $30. So I think anywhere probably between $20 and $100 depending. And the cool thing about these, this could be your ZWave network. So you can just bring one of these home and add individual devices. Obviously, you only have local access to your device, or up to 20 meters. ZWave says, I think 100 meters, but it doesn't really go that far, at least in my experience. But yeah, you can just add devices to your portable controller and have local access only. Yeah, cool. You guys got anything? Nope. Awesome. Well, thank you. I appreciate that.